So now we are going to start with the second session of the day. We are going to discuss about the present and future of the industry, and we are going to discuss about several technologies that we have some really nice stories that you can listen to. So without further ado, I want to welcome to the stage Professor David Romero. He is a professor at Montero University in Mexico and scientific vice chairman of the World Manufacturing Foundation. He is going to speak about us with a lot of global insights. So I'm looking forward to it. Thank you very much for coming to Athens and make all this long trip for us. Thank you very much.
Thank you very much for having me. Nikos, Stefanos, again, thank you very much for the invitation. Also, thank you very much, Nikos, for contributing to the World Manufacturing Report, which is part of the insights I'm going to be sharing with you. So I guess many of you have already started to hear a lot about what is going to happen in Davos this year. So the World Manufacturing Foundation could be a kind of a mimic to the World Economic Forum. But rather than talking about economy and finance, we bring things down to earth for what is relevant for the manufacturing sector. And we talk at the strategic and operational level about what it takes to remain competitive in this new world, in this new VUCA world. And in particular, this year, we look in the report together with a large group of experts around the world. Nikos, for example, contributed with a perspective of Greece on what is ahead, what are the new perspectives for the future of manufacturing with an outlook 2030, but also recognizing, again, that this is also part of the title of the blog that we're going to be discussing, what is the present, what is the future of manufacturing, of Industry 4.0 for many countries around the world. Definitely at present times, we live in a volatile, uncertain, complex, and ambiguous world, and we need to prepare for that. We need to look into the future to be able to design the future, because the best way to predict the future is to engage in its designing. And for doing that in this year, and we're going to be able to have access to the report, to download it, what we did in our effort to support SMEs, to support large organizations and governments was, again, looking into the future. This Outlook 2030 tried to define different scenarios and also different tipping points, critical milestones of things we need to be doing over the next years to be ready for the 2030. And once we reach this milestone from a technological, political, legal, social perspective, to be able to claim, hopefully, the dividends of our investments. We built in 4 scenarios, this outlook. The first one is the green transformation, and later on we're going to have a session on the digital and the green transition. But the green transformation as a growth engine for the future of manufacturing. We're facing, in some cases, a scarcity of resources, which is really pushing us to rethink how manufacturing will need to look in the next years in terms of adopting circularity, for example, as a strategy to cope with increasing prices, with the national protectionism that we're seeing in some natural resources, which is, of course, changing the way we trade around, for example, our raw materials. The second scenario is the technological divergence in the future of manufacturing, between having really digital divide or digital dividends. We talk a lot about the digitalization of the supply chains. And then, of course, we have a lot of lighthouses around the world, mainly being provided by the large companies. But when we talk about really the digitalization of supply chains, it's important to talk about how we're going to develop the SMEs, how we're going to be working in a next generation of supplier 4.0 development programs that will really help to transition into better digital and green performance across the whole value chain, the whole supply chain. So at the end, we have our value chain delivering the green, the digital performance, the competitive performance that it's needed. The third scenario is the refocus on core capabilities, and this is bringing, again, back the science into the way we operate, particularly when we look into material sciences, new manufacturing processes that are going to be required to design more circular products, to design the digital services to support the manufacturing ecosystem. And the fourth one is the regulatory fragmentation and efficiency focus. And I would say that from the 4 scenarios that we were working on, this is mainly the less perhaps desired, right? Because it's just focusing on continue doing what we have done, of course more efficient, in a more efficient way, continuously to optimize. But when we talk about innovation, optimization, incremental improvement, last to a certain point where we reach the limitations of any optimization efforts. And then going really from one S-curve of innovation to the next one even becomes more challenging. So of course, as always, thinking in terms of dual innovation efforts for many companies is challenging, but this is something that we need to look ahead to be able to be ready. I already mentioned to you about this strategic exercise that we did. We were looking into the future. We provided 4 scenarios for you to think about, but as I was mentioning, as we look into the future, we just cannot wait the future to reach us. We need to have a strategic roadmap of what we need to be doing over the next years to be ready for this critical moment that in many cases when we do road mapping exercises, we always need to put, okay, where is the critical moment into the future that we need to be ready? But on the way, there's a lot of tipping points, a lot of milestones of things that are happening or things that we need to be doing to be ready. And to this we call tipping points. Tipping points is a moment in time that when it has reached it, whatever you have done before, if you have done it in the right way, the benefits of your investment is going to ramp up very quickly. If you haven't done anything or if you haven't done it in the proper way, the negative effects are going to come very quickly also. So it's really about the criticality and what you're doing to be prepared for the future as future starts to reach you. So for doing that in the report, we look at the different geopolitical tipping points, economic tipping points that are going to be happening over the next 5 years. We're seeing already how the way we trade is changing. We're having the phenomenon of these trade wars and economic decoupling and a little bit of the deglobalization, if we wanted to call it. From an economic tipping points, a lot of the traditional business models are becoming obsolete, and we're already talking about circular and servitized and digitized and data-driven and AI-enabled business models. So we look into all these things. We already talking about the need for energy efficiency, smart manufacturing, or even water efficiency, smart manufacturing over the next years. We're also looking into social tipping points. So the workforce demographics is changing. We're needed to think in new ways of designing work and workplaces, in many cases combining it with technology to make people more productive. Technological tipping points, again, as we look into the 2030, and also it's very important to say that not all of these tipping points are bad. Some other tipping points are good. We're seeing in terms of, for example, of technology. Technology is becoming more democratized, more accessible, more affordable for the SMEs. The thing, of course, is do we have the people with the right skills to use this technology to make our production more efficient, more productive? We were also looking into different legal tipping points, environmental tipping points, how regulations are changing in terms of like managing the privacy of data, which is becoming more and more relevant to create it, value added in terms of digital services or smart connected products. in terms of environment to make our operations more environmental friendly, our products, again, more circular. So we were looking into all these positive and negative tipping points and combining them with the different scenarios. For us, was an exercise of how we can future-proof the future of manufacturing, how we can future-proof our supply chains, the operations of our SMEs, which are the backbone of all our economies around the world, and to do so for each of the different situations that we're looking, the different tipping points. What we tried to do in the report was to define an action framework. So what are the drivers, the pressures, the state, the impacts, and the responses that we need to take to be ready to future-proof our manufacturing sector. So from a geopolitical tipping point, definitely resilience is going to be very relevant. Resiliency coming again from economic drivers or could be from environmental drivers. But in this sense, definitely one of those entities that we need to engineer into our manufacturing companies and their supply chains is resiliency. And for doing that over the years, also we have worked in different reports. So all of these reports are available for free for you to download, but definitely working into the redesign of our supply chains and our operations is going to be extremely relevant to add resiliency to them. From economic perspective, we need to have more agile manufacturing business and operating models. So that means reinventing the way we create profit. So we starting for some years now to talk about product service systems, industrial product service systems. Just selling products is not sufficient. We need to add to those products additional traditional or digital services to create more differentiation and make our value offerings more competitive. So again, we combined our report of this year with some of the previous reports, like 2023, we were discussing about different archetypes of new business models that you can apply to make your operations more agile. Some social actions, we talk nowadays with, still working with the industry 4.0 in Europe. We're already talking about industry 5.0, which means like becoming more human-centered, more sustainable, more resilient, but particularly I would say that human-centered, as it needs to be, it needs to start with the people, needs to start with the skills, and technology is always going to be as good as its users. So many times we hear from the SMEs, okay, it's challenging to acquire the technology. Nevertheless, technology is becoming more and more affordable. But the most important thing is how I guarantee that I have the right people that is going to be able to understand the technology and marriage in the right way with my processes to really create a differentiator and a competitive advantage with the use of that technology. Technological actions, so how we can technology enhance, and I would say it is important to say it, how I can enhance my manufacturing operations and supply chains. So far, even though we say that, okay, automation, AI, robotics are changing the way we work, so far what we have seen in many reports is we always get the best combination when we're not trying to replace the humans, but we're trying to pair and we're trying to create new forms of teams where AI works together with the workforce, where robotics works together with the workforce, where automation works better with our workforce. Legal actions, regulatory compliant, especially from an environmental perspective, is becoming more and more relevant. And this means that we need to re-engineer some of our processes to become, again, more circular, more resources efficiency in the way they operate. And finally, environment actions. So even I think we need to, in some places, to think even ahead is not only thinking in terms of circularity, in terms of trying to reduce, in some cases, the damage that we have done over the past, but it's really how we can rethink the way of manufacturing as a way of contributing to regenerate our ecosystems. So it's not, I think this is maybe a little bit more beyond 2030, but I think it's not rethinking our business processes and our business models only from the perspective to make it more environmental friendly, but how we can build a manufacturing business and operating models that are capable of giving back more that they have taken out from the planet in order to be able to deliver different products and services to the market. Finally, as is a tradition in all our reports, right, we try to provide the 10 key recommendations, in this case for future-proofing manufacturing. So we have discussed, okay, we have different scenarios as we look into the future. There are different positive and negative milestones, events that are going to be happening that we need to get ready for them. We provided different archetypes of frameworks to develop different strategies to make your operating and business models at the factory level, but also at the supply chains level to make them more agile, more resilient, more human-centric, more technology-enhanced, more regulatory compliant. And finally, how to do this. What are the recommendations that we collected from a big panel of experts where we interview different C-suites and policymakers? Our 10 recommendations are the following. We look into the future, to be sincere, it's going to be challenging. It's going to really be characterized by this volatility, uncertainty, complexity, and ambiguity. But in order to face this, we need to develop agility, adaptability, and resiliency. Technology is there. Also, I think the way we strategize, the way we look into the future is changing. Technology, business intelligence, data analytics are helping us to be able to become better, to forecast what is going to happen in terms at least of trends, patterns that we're going to be seeing and getting prepared for that in terms of creating new opportunities, but also preparing some contingency plans when things may go sideways. To foster manufacturing innovation, so creativity, ingenuity, entrepreneurial thinking is going to be very important because, again, a lot of the way of operating is getting into a point of really obsolescence. We cannot continue operating in the same way and expect it to have those big breakthroughs in terms of productivity that many of our economies expect. So we need to think differently. We need to plan strategically, what's already been mentioned by Raymond. It's challenging in this way because we know that SMEs most of the time are only focused on their daily operations, but we need to, bring up our heads and look into the future, and that was also part of the motivation to combine, to find a balance between day-to-day operations and the long-term vision, to manage the risks. Risks are always there. Risks cannot be avoided, but we can learn, again, to manage it. And normally those who are brave enough to bet into the future, even though at the beginning it's a little bit challenging, really at the end of the story, after a couple of years, it shows that those become brave ended up, getting better results than those were not brave since the beginning to think different and try to manage the risk rather than just trying to avoid it. Also has been mentioned, the idea is not to, by Dominic, the idea is not to reinvent the wheel. I think there's a lot of best manufacturing practices out there. The idea is to how we can just avoid reinventing the wheel, just simply adopting those standards, those best practices to do what is the minimum to remain competitive. And then, because we're already focusing on the best manufacturing practices, it becomes easy to create time to thinking in terms, again, in terms of manufacturing innovation, what could be the value practice that we need to develop to create a differentiator and a new source of competitive advantage. Sustainability, it's a business opportunity, I believe so. It's not, again, some regulation that we need to comply. I think there's a lot of opportunities, new business opportunities for that. And one of those, of course, is what are the new possibilities that digital and green transition can offer when they work together. Talent and leadership are very important. Again, technology is going to be as good as its users. And actually, there's one definition that I really love about what makes manufacturing smart, what makes Industry 4.0 smart. And for me, is really the marriage of information, technology, and the people ingenuity. Because it's really the source of competitive advantage doesn't come from the technology per se, doesn't come from the data per se. It's like how we can combine those technologies, and it's really coming back to the basics. Again, it's not trying to reinvent the wheel. It's the people, it's the process, and it's the technology, but the secret sauce really comes in what degree you are combining these three pillars. And then, also mentioned it many times here, if you want to go fast, you can go alone, but if you want to go further, you need to do it in cooperation, you need to do it in collaboration, and that's why we are all together discussing how we can move forward and be prepared for the future, working together, and again, sharing our experiences, sharing our best practices, but also common mistakes, and use this to move faster and further together. So we believe that, yes, we live in a VUCA world, but with the right mindset, I think we can change the volatility into vision, the uncertainty into understanding, the complexity into clarity, and the ambiguity into agility. Thank you very much for your attention. And if you're interested in our report, please feel free to scan the QR code. And at the same time, while also moderating this session on the present and the future of Industry 4.0, I think we have a couple of minutes for questions for myself, and then I immediately jump into introduce our next speaker. Any questions, comments, reflections? Don't be shy. Seems I was very clear with my presentation. Of course, we are here the rest of the day. So in terms of the sake of managing the time, right, and catch up a little bit with the agenda, let me introduce Professor Dimitris Kyritsis from EPFL and the University of Oslo. Is going to share us about information modeling framework and ontologies and more. And I think this is especially the idea of the ontologies, right? It's like how, if we want to be really efficient, we need to learn to better interact with the data and better interact with the technology.
Go to the meaning of the data.
Go to the meaning of the data, exactly.
Good.
So
thank you.
I leave you the stage.
Thank you, my friend David. Thank you all for being here. I am Dimitris Kyritsis, so I was at EPFL until May last year. Now I am at the University of Oslo, advisor there, and also I'm very happy and proud to be advisor at the Swiss Smart Factory and work together with Dominic that you heard before. And so I have the privilege, after setting the scene of David, to, my opinion, also put a little bit the scene of what we do with data. So we are in the data-driven economy, Industry 4.0, but we don't make decisions based on just data. Data are what we collect from the world with senses, our senses and other sensors, but we take decisions since the beginning based on information. I will try to explain a little bit what are the means, the technical means that we are developing at the University of Oslo today to do it. So the motivation is, again, how to make decisions. And decisions are made through the agreements of experts. I mean, in industrial settings, also in other settings, also experts are discussing together until they arrive in a compromise solutions. In the engineering environment, we have models, we have our own languages, technical, starting from the beginning from technical drawings and other kind of drawings. We follow standards, and we have to obey to business decisions, to business motivations. Business models also are a guide for the efficiency or what we want to do. So now we're in a data, let's say, driven economy, as I said, and we have to see how these technologies may help the process of decision making in an efficient way. Efficiency is always something that we are looking for. So since about, let's say, the Industry 4.0 was born, so what we are able to do with these technologies of Industry 4.0, which is Internet of Things and data captured by sensors and made available in the cloud and various stakeholders in other data sources. So we are able to be connected, and we are exchanging data among us, the stakeholders, I mean, users and service providers. And service providers may be also systems, not only humans. We, through the Internet of Things, we exchange, share data, we transform them to information and to knowledge, and we make decisions better. I think decisions faster, which is also part of the efficiency, and we are able to follow all this, what happens along the life cycle from the beginning of life to the middle of life to the end of life, or whatever is the subject of our activity. So my experience with that started 20 years ago with the first experiments with well-known partners on what if we embed this kind of product-embedded information devices, sensors and ID devices, wireless devices, collect data from a system through its life cycle, and what to do with this data. So this was my point, let's say, interest of research. So after this first attempt, I realized that around 2008-10, that it is coming the era of big industrial data. And the question is how to explore this data. And I think all of you know, you are involved in European industrial research and innovation. Only 20% of the data collected today by industry is used. The rest is not used. Hopefully it is stored or not stored, or let's say maximum 20% is used. So how to make, let's say, efforts to make good use of this data. For me, in the engineering domain, is not just explore data or analyze data. For engineers, it is necessary to go to the meaning of data, to capture the meaning of data, understand it in terms of meaningful information for me to make a decision of what it is going to happen next with whatever we do. So this is a graphical representation of what we call an ontology, which is a semantic model that tries to capture the real world by means of entities that we, as we humans, perceive these entities of the real world with our mind. So you see here, starting with an instance, which is a value of a temperature, which is about a body temperature or an oven temperature, and then this is something like a quality. You see that we are able, with ontological semantic models, to model the world in various levels of abstractions, and this is important because our mind thinks in various levels of abstraction, not just numbers. This gives this starting point of a methodology that helps to structure the data that are available here and there in various forms by using appropriate methodologies like the user story mapping and capturing the domain knowledge. So this now is happening doing iterations with human experts, but LLM and similar AI systems may help to automatize also this work. So this helps to organize the data in terms of semantic models, ontologies, which is the foundation. So the meaningful, I would say, foundation of a knowledge graph where we store data that are linked together. And what is happening now by industry is apply data analytics or AI algorithms, machine learning, or all these kind of techniques, algorithms on data that are structured on knowledge graphs. I'm sure that all you follow what happens with LLM ChatGPT, and if you follow what happens, you know about the RAG graph, which is the state of the art of structuring data also in the certain industrial sectors in terms of this kind of graphs. So from my perspective, the engineering, developing of engineering systems based where we are using models is how to start integrating models in an efficient way to make decisions with the support of software systems. This model integration happens today in meetings among experts. Every expert, the electrical engineer, the mechanical engineer, the automation engineer, creating a dialogue with his colleague of the other discipline based on a model that he or she has about his or her system. And this dialogue happens interactively with discussion. The question is how we can, let's say, with software systems, make an effort to make these models interoperable and integrate them as well. Digital twins is a tool to do that. This happens also today. With digital twins, we are able to exchange information messages between models. This picture comes from the group of Siemens, where they classify digital twins in categories of product, digital twin for products, digital twins for production, where we create products, and digital twins of performance, how well we create the products, how well the production system operates. All these software pieces, the digital twins have to work also together and respect other requirements. A new concept that where is my also interest of research is what we call in some of our also common research projects, cognitive digital twins, which is how, let's say, explore whatever we can learn, whatever we can do with digital twins in terms of creation of data that are associated to the data that we create from the physical world, how to integrate them. Data from the virtual world with data from the physical world. We can do it by modeling them in semantic models and integrating these semantic models. This helps to create an integrated knowledge graph, which is the foundation for a graph database where the data are. And this is what some people call single source of truth, SSOT. And this is the reference where applications like the new term, trendy term, AI agents or other decision support agents or other software make reference for their data. So this is research published in 2021. This slide comes from a company, Equinor. Equinor, you see the logo at the bottom, is the Norwegian company of oil and gas, state company. And this is how they see the future of information systems. And I discovered this 1 week ago, and I think it is quite similar to what I said before, which means we have sources of data in various forms, including digital twins. AAS is the standard of Industry 4.0 asset administration cell for digital twins, or other things that you know better than me. Data are there. Using ontologies, foundation, schema, which is based on industry standards, we create knowledge graphs, ontology-based knowledge graphs for the data, the sources of data that we have. Context is embedded, so I don't want to go to technical details. Context is based in knowledge graphs, and we use this knowledge graph, as I said before, as the single source of truth to have access to the data, and this is to be consumed by various types of users through tools that are available today. Hype AI agents. You will hear, if you don't it's not, you have no experience with that, you will hear many, many times this term. It is also funny because the multi-MAS, some of you may know, multi-agent systems, were at the research point at the end of 90s, beginning of 2000. Now it is coming back with realizations by means of AI tools. Also, standards. Ontologies should be based on industrial standards. Ontologies will represent new industrial standards. And we have to create standardized ontologies to be used by various industrial sectors. So these standards are created by communities. So you have 3 of them listed here that are now active in creating this kind of ontologies standards. I am involved in the first and the last one. I helped to create the first one, by the way. So what we are doing now, why I went to Oslo, because there is in Department of Informatics a team working with the oil and gas industry there since years. The Norwegian oil and gas industry is among the first to use semantic models for their business. So they made the same, let's say, observations. The observations that all business do, that all these sectors, they have to work together. And all the operations are fragmented at system level and human communication level, etc. How to break this fragmentation by offering a framework where we can model information in a meaningful and common way. This is the objective. And the information modeling framework tries to do exactly that. And what I did in the past fits well with that from another point of view, the manufacturing point of view, and the development of different similar experience, and we try to do that. So what is IMF, Information Modeling Framework? It's first a framework where we can build solutions, and a language which helps to transform models. The important thing is that we start with the modeling of the system. Model-based engineering, model-based system engineering. The first level, the first, let's say, starting point is create a model of your system in order to understand it, in order to identify at the system level where are the data points, where are the sources of data, and how to capture them. And using, as I said before, abstraction levels, cover the asset life cycle, communicate. We have always to communicate with subject matter experts so that this, at least the starting point, the system model must be quite simple for them to use. And based on technologies that I have already mentioned, this methodology, the IMF, is also already available in the first link, where the manual is there and other material, but also by DNV as a recommended practice. The main aspects that we cover in the system model is the function, as every engineer does, I think, correctly, and the product that helps realizing the function. And as an example, this is an UFD, utility flow diagram of process engineering in the oil and gas sector. This is a system model that helps to organize the work for the first drawing to be realized. Modeled in SysML. In my opinion, this is quite complex. And we use now this standard, the 81346, with blocks, connectors, and terminals that helps to categorize the various disciplines, and at the functional level, also the product level that realizes the functions. And the thing is that these block diagrams are integrated together, and you can add also properties, values, etc. This is the overall architecture where, I don't know if you can see here, so this is the first when we capture the business logic and the system, and using the IMF tools, the 81346, we create the graphical representation of the system model, which is by using the language. The IMF language is transformed in an ontology. OWL is shackler languages to code ontologies in computers. And RDF is the way that this ontology is represented in a knowledge graph, and then you have the graph database. It's not too complex, but it requires some steps to be realized. This is what we do, and we implement that in a number of funded projects, and what is our target in this kind of projects with various industries is to integrate the framework together with a framework of building solutions in terms of digital twins or other decision support agents, including AI agents, in various cases to help engineers to do the work more efficiently based on information and data. And I stop here. Thank you very much. Questions?
No. They changed a little bit the program. So do we have any questions from the audience? Do we have? Otherwise, I will be a little bit provocative, yes, right? I mean, I always believe that we live in a data-rich, information-poor, and decision models world, right? I mean, as you say, data is out there available, and then to transform data into information, we need to provide meaning, understandable meaning to the data, and I think that's part of the role of the ontologies, but also doing business intelligence, doing data analytics, crunching data for the sake of, let's see where we discover. I think that's where maybe manufacturing is different to marketing, right? We're not trying to discover things. When people say, okay, let me do data analytics to understand quality, whoa, I would say, I'm not sure I want to buy from you if you're trying to figure it out that, right? Is to, you know, augment our decision, improve our decisions with new technologies. So my question is how we can understand how to better, you know, define decision models to support the decision making, because also I think Dominic was saying, right, it's like, what is the relevant questions that we should be asking ourselves as manufacturers?
I think both approaches are good, but when they are applied to the right problem. So data analytics in the way that you presented are good in some sectors, in social media, for example, or in pattern picture recognition with the automatic driving. When mathematics, statistics, and probabilities are good tools to go to a required level of accuracy, of probability accuracy, more than 95%, to apply it. So in the engineering domain, as I said, we have to go to the meaning of data. There is a reason for this data to be there that comes from the physics of the machine or of the product or of the material. So we have to identify the source of data, discover the meaning of this particular data that we measure in relevance to the source of data, and explore it. So just statistical or, let's say, probabilistic data analytics of sensors that we have on physical assets, for me, it's not enough. We have to go with the link, the data, with the physics, the models, the physical models, when we can have them from the physical world, and try to discover this meaning of data.
So we can really close the loop, right? I mean, it's like, at the end, we need to make decisions and take actions that we don't understand. Then it's really hard to come back and actuate on the real world.
In the manufacturing world, it may happen that we have a lot of data from the history for quality, for example, tolerances, etc. There, focused, let's say, mathematical analysis of this data may help us, give us, let's say, extra information to model the ontology more correctly. We can use both technologies. But the starting point for me, for industrial applications, is go and capture the meaning of the data based on what we know about the domain.
Thank you very much for sharing with us. So big applause. So we use applauses also to wake up a little bit, to get energized. So our next presenter is Dr. John Soldatos, which is going to share with us about generative AI in industry and the role of LLMs. Please join us on stage.
Thank you, David. Hello. In the next few minutes, I'll present a vision for the future of artificial intelligence in manufacturing, and actually the future of the agentic factory, the factory that will operate based on autonomous artificial intelligence agents. So actually three things I would like to share today. First, where we really are with generative AI in general, but also in manufacturing and production in particular. The second thing, how the future agentic factory may look like, and what is really the term AI agent, what is the essence behind it, or if it is just another buzzword, and closing with some thoughts on what might mean for factories the roadmap towards AGI, artificial general intelligence. So it's all about the explosion of compute capacity. And nowadays, we know that the semiconductors industry, NVIDIA in particular, is the company with the highest capitalization, catching on this Apple and Microsoft. Last week, in the CES conference exhibition in Las Vegas, NVIDIA presented maybe the ChatGPT of manufacturing and of physical processes, the Cosmos platform, which is a platform that can operate, can act as an autonomous robotics platform, recognizing movements, being able to produce synthetic data trained on 20 million hours of footage. We know from our EU projects what is the challenge of having data. Now imagine there is a system nowadays trained with a lot of data that can understand physical processes and even produce synthetic data. And this might be a game changer for physical processes and production like ChatGPT or LLMs were 2 years before. So what do you need to know? First of all, that this is really the explosion of technology acceleration. 12 years ago, we introduced the term Industry 4.0, but you see it's hard to scale this up, to scale up the digital twins, the IoT processes. Now, the explosion of compute power and of data is the opportunity to scale up Industry 4.0. Another thing that you need to know is that there is already some AI tool already available or already being developed that is doing everything you might need to have. Generate a 3D model or generate software code for your factory. So there is a very big ecosystem of AI tools which are improving. There might be some doubts here, but in terms of the size of large language models, we see a new Moore's law. So these models having already trillions of neurons when we see in terms of model size. Another important point is that these models cannot just generate text or 3D models or code based on their training. They can also think. I put this in a quotation mark. So they can also reason. This is, for example, what the O1 and now O3, which is under security scrutiny, models are doing. So not just outputting some text or some output, but also being able to reason. So it means this gives a capability to optimize production recipes, to optimize production schedules, production configurations, all of this by using the reasoning capabilities of a large language model. Now, with all this, we can already start using generative AI for things like producing automatically multiple configurations of a product, easing the access to databases, for example, manufacturing knowledge bases, much more efficient training, industrial training, and also much more human-centered, like what we call Industry 5.0 and human-centered manufacturing, but also through reasoning, the opportunity to better streamline processes. And I claim that all of the use cases you can run today using the models that we have today in LLMs. Also, you have these systems like NVIDIA Digit projects to deploy these models inside your factory in edge computing configurations so that you don't have to rely on cloud services by vendors. Now, and this is what you can already have in 2024, in 2025, but today I think Professor Kyritsis already mentioned this term. 2025 is all about the word AI agent. And many people think if this is just another buzzword, right? So I'll try to break it down. I've recently gone through all the definitions of NVIDIA, Google, and I'll try to break it down to you what I understand in terms of an AI agent. So first, it's a software that can do something on your behalf. That's the definition, the etymology of an agent. Like put some information, write some information on your ERP automatically. But it also has a decision-making layer, which means prior to putting this entry in your ERP, it can perform some quality control using artificial intelligence. So there is a decision-making layer. And most important, this goal-oriented software is autonomous, is specialized, and it is autonomous. So it can take autonomous decisions about the quality control, the predictive maintenance, based on its AI training and AI knowledge base. So it can act autonomously, take decisions. If needs be, it can communicate with other agents and humans alike. So it doesn't really sound like a simple microservice, but it's a specialized software that can perform work with you in an autonomous way, which gives you much greater autonomy and scalability in the process. So an agentic factory is grounded, of course, based on knowledge graph and the modeling of processes, the real-time integration of data so that this improves, and this gives the autonomy, not just a predictive maintenance that is trained once and then retrained, maybe in a very coarse time scale, and also a multi-agent infrastructure that can put different agents, a production scheduling agent, a predictive maintenance agent, and quality control agent in a way that they can be coordinated, orchestrated to build complex automations. So 2025 is the year of AI agents. This is what all big companies and all big vendors are trying to do in the artificial intelligence industry. And this extends to robotics and physical systems, which is actually what we need in manufacturing, not just software bots. Now, once you do this, you get greater autonomy, you reduce the human oversight. I'm not saying that the human goes away, but you need to have less human oversight, and you scale all the processes in the factory up. And the vision is what is called the intent-based computing and intent-based factories. Nowadays, any digital system needs to be programmed with detailed instructions. We are having a shift from instruction-based computing to intent-based computing, where you just stress to the system what you want the system to do. Now, this is all part of a wider roadmap and a wider storytelling towards what is called artificial general intelligence. A quite vague term for me. I don't like the definition that this is something that it can do everything better than the human. But there is a roadmap towards this AGI. And actually, the transition from the simple chatbot to the AI agent is one step in this roadmap. And the next step is to be able to orchestrate multiple specialized agents to solve complex problems. At some point in this roadmap, by the way, this roadmap is from OpenAI, but other companies have similar, you have societies of such agents that can innovate. This means that at this point, you won't rely in your conventional production processes that we humans have invented and apply for years. But depending on the data, agents will be able to suggest and to implement alternative production processes. And that will unblock a new intelligence in terms of manufacturing, where you will be able to state your manufacturing business goals, your production goals, and then let the agents do lower level work. So in conclusion, I believe that every company and manufacturing and production enterprises, despite some conservatism in this sector, there won't be an exception. They will have access to a layer of intelligence based on their own data, based on their own knowledge, and by using AI. It's not a single use case. It is rather an access to a layer of intelligence for every manufacturing use case that exists. Maintenance, quality control, scheduling, supply chain optimization, and so on. So this is takeaway number one. Prediction number two is that future factories will comprise a range of collaborating agents, software, but also robotic systems, industrial robots, cobots, each one acting autonomously. You can think of it like a digital worker, a digital human being able to communicate with other humans and with other agents. And this will allow us to scale production at unprecedented levels. Let's see if this comes true in the coming years.
Questions, comments? Yes, please.
These explanations about AI agents, you gave some examples, predictive maintenance, quality, etc. But we have the same terms with reference to digital twins, so digital twin for predictive maintenance and so on and so forth. So do you see any difference, or it is not a synonym in my opinion, but how we have to cope with these two terms?
I think the difference is in the autonomy, right? So digital twin remains as a term. The promise of the AI agent is the autonomy. It's not a module that operates with supervision in a way which is semi-deterministic, but it can be autonomous. It can be a digital human. So this is point number one. Now, I think that you made a good point. My examples probably were not right because especially as we go down the road, it doesn't mean that we are going to model the factory agents with a conventional thinking. So what I did is I took different workers in the shop floor and I mapped this to AI agents. But this doesn't have to be this way. So this is an area of research. This is an area of innovation of how we distribute production work, how we distribute industrial processes to a new team of digital workers, digital humans, AI agents. And it does not necessarily have to be the same as it was happening today. So maybe my examples were not the right one, the right ones were not what we are going to see in the future, were just something which was easy to understand because it related to the jargon we are all familiar.
Yes, please.
For this. So in my opinion, so in my understanding at least, so as you say, the future will be agentic. But not all of all these agents need to be AI agents. So humans are also can be seen as agents. Robots, AI agents, digital twins are also agents. So this may help to configure our vision for the future. Thank you.
Thank you very much, John, for your presentation. We have any other further question for John? Okay. One more. Otherwise, we start to get too jealous because you got 3 questions. So.
No, 2 is okay.
Thank you for the nice presentation. I'm Yorgos Kasparis from SCCH in Upper Austria. I will dare to ask if you can make a prediction about the time frame for such, let's say, scale up or including AI in industry. And the reason for asking is that I come from control and systems. And as you know, maybe in 1890s, there was a big buzz about adaptive control and robust control. And in 2024, in Upper Austria, in most industries, the most digitization that you find is a PID control. So it's very difficult for me to imagine that this will be seen soon. And this is the basis of my question. Mainly because there is no trust in technologies.
Actually, maybe you know, I'm amongst the older people here, so older guys like me certainly remember that the term AI agent or even AI agent is not new. However, now we have much more tools to make this happen. And the tools are compute power. We have this compute power. We have the data explosion. So it's not, yes, the concept of an agent or of adaptive control is nothing new. It's true. What is new is the compute power we have, the data we have, and a whole new industry working on this concept. So in my eyes and in my prediction, the technology is there. Now, how fast are we going to be to adopt it is the question mark. Today, as we speak, less than 10% of people use ChatGPT. I mean, knowledge workers. You've got a powerful tool there, but very few people ever use it, which is not a physical system. It's just a digital system, so it's much easier to use. So in this context, it's going to take time. But like In the 90s, somebody said that everything will happen over the internet, and it has happened. Nowadays, you can do everything from your banking transactions to your retail shopping, everything over the internet, and it happens. In 2007, when the iPhone was introduced, the smartphone, some people said there will be a mobile app for everything, and you will be able to do everything through a mobile app. And it was a safe bet, because it has happened within 15 years. So I bet that every application and every use case in the factory will be accessing a layer of intelligence, a layer of digital intelligence coming from generative AI, most likely large language models with your data. So I think this is a safe bet for the next 10 or 15 years. Then the autonomy and more futuristic things is another more difficult bet. But I can safely predict that in the next 10 years, every application in your factory will be accessing a layer of digital intelligence.
Thank you very much, John.
Thank you.
Well, just to try to keep with, or I would say catch up with the timing, let's move forward. Of course, we're going to have lunch. Our speakers are going to be here, so you can further address them. So our next presenter, please join us. Dr. Foivos Psarommatis. Yes. Digital Product Passport for Industry 4.0. Very interesting. We already started to talk about, modeling information and building intelligence around that information. But one of those applications, how we share information, how we use information, is the Digital Product Passport. Very relevant also for environmental performance. So please, the stage is yours. Here's the clicker.
Thank you very much for the introduction. I'm very happy to be here. We will talk about a concept that it was introduced by the European Commission, and it is the Digital Product Passport. And there is a lot of buzz around this term, let's say. And I will try in those 10 minutes to explain in practical way what it is and how it can be used. So let me start first of how it was created, the need of such a technology, a methodology, a way of thinking, I will say, because it doesn't have specific technology. There are other technologies to implement it, but it's a different way of thinking and organizing data that we will see in the future. So the actual problem that we wanted to solve is the sustainability, the circularity of products, and making processes more efficient. So based on consumers wanted to have products more circular, more sustainable, but the question that everyone, I think all of us, we have thought about it, how sustainable it is. How circular, how we can measure it. Currently, there's a lot of difficulty of measuring that. I think all of you have faced this issue. And for that particular reason, for that reason, EU has created, let's say, a new regulation, which I will show you later. These are old version of my slides, so I will go through later. So what it is, the Digital Product Passport? It's a way of sharing data among the entire life cycle of a product, from the beginning of the raw material collection to the recycling and going back to the stream again. So Digital Product Passport, it's about three things: transparency, traceability, and trustworthiness of the information. And having this can give a lot of power and efficiency to the technologies that John described before. If you have traceable information, this means that you have information with context that can train models in a more efficient way. So what are the problems that digital product passport solves? First of all, okay, we said that it's regulatory compliance. Okay, in order to comply to the new regulation that the European Commission has created. But it's not only that. It can be used for increasing the efficiency, reducing the waste of not only the production, but the supply chain, the entire supply chain, because it identifies where there is an issue. And okay, the question comes, okay, why we cannot do that? Simply it's because either we don't have the data or the data are in a form that we cannot extract such information. Of course, it can help a lot on reporting. We will go through later to that point. So do we have to invent everything from scratch, or do we have to, how easy it is to implement it? And the answer is that 80% of the data that should be on the digital product passport already exist. They are on the database of all the companies, but as Professor Kyritsis said, they are not using it. And why they are not using it? It's because they are unstructured data that has no meaning. So the digital product passport is there to connect the information that we have on the databases with product instances. Meaning, if I am producing this presenter, I will know what piece of information are related to this particular instance. If someone else buys something, another one of the same one will have different information. And having the data in such granularity and correlated gives you a higher level of efficiency into the different activities that you want to do. So 80% are the data that are already there and can be reused, and you can already have a benefit from that. 20%, they are new information that currently we didn't have the chance or the means of capturing them, or they didn't want to capture them. So this is basically how they are related about the data that we need to populate the digital product passport. Now, let me explain, because, okay, we say digital product passport, but what it is, how it looks, how we can actually create and capture information using that. So we have simple components. So if you produce a product that is a simple component, it's just one digital product passport. But if you have complex products, which is the case in the majority of the products on the market, this means that each component that is inside this product has its own passport, and in the end, you have a bigger entity that holds all the information. And if we want to see it from the supply chain perspective, we call the term information inheritance, meaning that you have the different supply chain nodes, and you see that you start from the beginning, which is, let's say, the raw materials collection, and then you process them, and you add information, and you add information in order to reach the final step, which is the final product that holds all the information. But here is a very critical, let's say, an important point, which is information sharing. Companies have secrets, so you need to have specific, let's say, data sharing policies in order to assure that only the information that you want to pass on to the next supply chain or node will be transferred, because the digital product passport can be used not only for the supply chain optimization, so the entire value chain, but also for internal use, for optimizing the internal, let's say, activities. So it's in the matter of each stakeholder which information will pass to the next node, and which information will be publicly available in the final product. So the digital product passport should cover not only a specific node of the supply chain. In order to affect, it needs to be applied to the entire supply chain and to the entire life cycle of the product, from the raw material, the processing, the manufacturing, assembly, the product use, A very good example for the product use is I think most of us, we have a car. Inside the glove box, there is a small notebook that the mechanic writes what the maintenance was. This is a part of a product passport, but it's not digital, and it does not have the information that you want to capture. So the term product passport exists. We have it in our lives, but the digital product passport, it's a way for automating things. And if I want to put it on perspective, what kind of information we should capture on the digital product passport according to the life cycle, we see here that we have information about material, the environment, manufacturing, maintenance, the value network, circularity, and from the end user. And we see in each phase which piece of information is exchanged to the digital product passport. Now, there are many benefits that the digital product passport may give. We separate them internal benefits and external benefits to a company. So in a nutshell, those benefits are in terms of you can optimize even better your production. You can reduce the waste. You can build a bigger, higher, more strong brand reputation. You can be transparent to your customers. You can automate reporting. You can do many things because the key for the implementation of Industry 4 is data, and everything relies to data. So if you have, if you can have the data in a better form in order to do your activities, then this will give you more power in order to produce excellent results. So I talked about the regulation. I will go through since the time passes by very quickly. So in a nutshell, digital product passport will be mandatory, and either you are manufacturer, supplier, dealer, distributor, you need to have a digital product passport to write some information there based on what the product owner wants and the regulations. So also in together with Nikos and Stefano, we share the same principle, not only doing research, but also providing products to the market. So we have built a complete suite for digital product passport capturing the entire supply chain. And here are some key numbers that we have found out that could benefit companies. So you can reduce decision time significantly. You can reduce waste, cost, and you can automate reporting. We spend hours for reporting and trying to calculate numbers. Using the digital product passport, you can automate that and save time, save costs, and be more efficient and actually more accurate. So finally, I will close with an example with one of our applications. Is that we applied the digital product passport in a supply chain for making this kayak boat. You can scan the QR code. It's a live passport, which is what our customer wanted. Okay, so you can draft it as you want. The information is on the back. So we start from the plastic collection, sorting, recycling, and making the kayak and manufacturing it. And actually, it's one of the first kayaks that it's 80% recycled plastic and not 1 or 5% that they are on the market. Yep, that was it from my side. Happy to hear your questions. Yeah, thank you.
Questions? Anyone? So we have already heard that the digital product passport is already being deployed for the battery industry, also textiles. When do you think it's actually, I mean, it's already somehow being running behind, but when do you think it's going to reach its maturity in other kind of products?
That's a good question. In terms of technology and platforms to do that, I would say maybe couple of years. But companies to adopt it, even the regulation implies to do that, it will take more time, I think, because they are very resistant to change on that. And sometimes it's very difficult to convince them what would be their benefit for that, because the digital product passport may have different effect to the company based on how the company is working. Because you need first time in order for the digital product passport to work, you need time to accumulate data, and then you will be able to give you the full potential of the data. So I will say 5 years. I want to be optimistic, but from what we have seen, that's the estimation. Although there are we already have implementation of the digital product passport, but it needs to be implemented in a larger scale of the supply chain and not isolated in a few supply chain nodes.
Okay, thank you very much for your presentation. I need to keep up with time. Thank you very much. Some applauses for Foivos. So our next presenter, Ignacio Montero, please join us on stage on asset administration shell. So we're still talking more about how we can better organize information, organize better our interfaces with that information, and particularly, well, asset administration shell is part of those tools to better engineer the communication between the digital and the physical world. So please, the stage is yours.
Thank you. So when we were invited to speak about asset administration shell, we felt it was like, well, we're here to discuss about not the most appealing topic compared to the other presenters. It's like going to a basketball clinic and ask you to speak about free throws. So, but you still need to make 27 points, 13 rebounds, and be the defensive player of the year, but you need to make the 70% free throws to be Giannis Antetokounmpo. So here we are to speak about something that is fundamental for Industry 4, that is AAS, and it's very much related to other aspects that have been commented and that are going to be commented afterwards. So you may know us in AIMEN from being a research center working on the application of advanced materials in manufacturing process and sustainability. But back in the day when we were starting to digitalize, we realized that we needed to have a way to structure information properly. And that's why we started to work on AAS. And we are here a bit to advocate for AAS as a fundamental step towards digitalization and to exploit data properly. So many of the fancy things you've heard before and that you'll hear after, you cannot do without structuring your data in a proper way. And AAS has come for this. So let me address the elephant in the room. Normally when we talk about these things, it's the concept of digital twin, of course. A digital twin, everyone knows, is a digital representation of a physical asset, and it's fundamental for Industry 4.0. But I bet that most of you have been in a tough conversation where you're discussing about a digital twin, and probably people have different meanings for it, and you don't understand each other. So we're quite clear that it's a concept in dispute. We will try to explain why we call the AAS a digital twin, but this is not that important. So what we need to understand is where we position ourselves in this cube when we're talking about AAS. And in reality, in this kind of cube, you have different hierarchical levels for Industry 4.0 here. You have different stages of the asset life cycle here, and you have possible uses that you want for your digital twin on this axis. And in reality, AAS is based on the first phase of this. So how to digitalize product, process, resource. It can be a machine, it can be a telecommunication system, it can be many things at different stages or for different purposes along the life cycle of that asset. Okay? So playing with different kind of digital twins for different purposes and play with this kind of Rubik's Cube, but we must be aware that especially industrial companies can get very much puzzled with this, so we try to keep it easy and start by the fundamentals, as we were saying in the beginning. So what AAS is a try to standardize the digitalization of industrial assets by defining a number of submodels that represent that asset properly. It can be an identification part, the technical data associated to the asset, some operational data, et cetera, et cetera. And those submodels define different properties, different characteristics of this industrial asset, and it can be used for communicating that kind of information in a digital environment. So at the end of the day, it's a type of digital twin. It forces to standardize data, so it forces us all to speak on the same language. When we refer to a piece of data, we know where it's coming from, and we know how it's measured and where it has been measured. It allows us to implement proper data management politics internally in each of the companies. It facilitates interoperability of data among formats. We will show some examples later. It touches the full life cycle of the asset, and also it facilitates the integration with the IT part, because this is basically OT, so how to relate to assets that are in industrial field and get the benefits of the IT combined with this. But when you're talking about these kind of solutions and you're telling them you should start by implementing your AAS in a company, and you show them this, but in reality they want this when they're talking about the digital twin, there's a huge difference. And that gap is an issue, because if, I come back to here, if you're telling them I can deliver you this, but they want this, especially the CEO wants this, it's very difficult to sell. But it's fundamental, and we can for sure give you some examples now until the end on how the AAS is fundamental to reach metaverse, AI agents implementation, and so on and so forth in the future, starting by the free throws. So the first things first, we've realized that it's difficult to implement AAS in industry. And at AIMEN, we are working on how to make this simple and standard compliant. So we've come up with this, what we call AIMEN Shell Toolkit, which is a user-friendly interface for people to upload data and structure the information around their assets, how to validate that data properly, and how to connect through OPC UA server configuration. This is a bit of how it looks. You can add submodels to it. You can download it, upload it, exchange it, and so on. So this is a fundamental step for us to facilitate the uptake of the technology. We also think that AAS is fundamental for DPP. We've heard about DPP before, and it was commented that it's for connecting the full life cycle. So through data models embedded into AAS, you can have a structured way of organizing that information. You can even take advantage of that the information is properly standardized and with quality to apply to deploy a DPP afterwards. There are several initiatives behind it. There are some they're mainly private, but also in research projects, we are doing some work on developing DPPs that are based on AAS and apply them to different kinds of products. Here you have an example of the project we're working with JKN for aeronautics, consumer electronics with Fairphone, and also logistics centers with PESMEL. So the idea is that you can actually utilize these AAS structures to do the fundamental part of how to structure data for a DPP, and then, of course, you will need a DLT network to guarantee traceability, to guarantee immutability, and so on anyways. Another key part of this has to do with how to enable reconfigurability and agility in industry. And we were commenting that AAS is basically for modeling product, process, and resources. But with the rising of AI agents that we heard before, we need to understand how to deploy other kind of modeling through AAS. And this type 3 modeling that it's called, it allows to have active behavior attached to your asset. So basically, how to define capabilities associated to an asset, skills, services. So you can actually facilitate the deployment of an AI agent that is attached to your machine, or how to deploy a visualization system that allows you to see how production goes, or even how to digitalize workers and make them work together with AI agents in a shared environment. So that's also a major issue to address. And finally, I wanted to comment on how we see AAS being a crucial factor for data interoperability and exploitation of data. We'll have a presentation just afterwards about data spaces. So for data to be monetized, you need to have quality data. And that is something that many companies, we've heard in the morning before, that the way companies have been digitalized, they've purchased probably a huge server in-house, put in a lot of money that it costs every year in OpEx as well, quite some money, but they don't know what they have inside, and we see that quite frequently. So you go there and you try to deploy an AI solution for whatever, and you realize that it's quite far away from what they actually need to start with. And AAS will solve that out minimally because they will need to follow some kind of a standardized way of representing their data. And therefore, if you want to sell your data in an open data market in the future, having it standardized would be an essential factor for you to say that you actually have data with value for others. And apart from that, we are starting to see the viralization of AAS somehow. Because, well, you know, manufacturing is everywhere. We always hear about that. But also, when we start to attach a digital asset to a physical one, we are forcing AAS to appear in other sectors. So if we're fabricating a panel in a manufacturing location, but that panel has an AAS, and then you move to construction, probably people in construction want to utilize the data that it's in that AAS for other purposes. So we've seen a couple of months ago, IDTA has agreed with a construction sector institution to discuss the interoperability between AAS and IFC, so that we can get data from components or products that are in the manufacturing being produced and how to deploy them into construction sector. So I hope that with this, I can transfer you the value of being tidy and putting all your data together in a standardized way and the potential of utilizing standards to move that, especially in the manufacturing sector. Thank you.
Thank you very much, Ignacio. Do we have any questions? Comments? Yes, please.
Thank you. I would like to ask you if this has something to do with the digital passport, digital product passport that we spoke before. Is there any kind of relation between this AAS and the digital passport?
Yes, indeed. So the reality is for us that independently on what you want the data for, you need to structure it, and you need to structure it in a standardized way. So at least our claim is that AAS is a fundamental layer for you to deploy a tool that can be a DPP, a digital product passport. And for me, the key issue here is that you can decide to standardize your data independently on wanting to have a digital product passport or to apply an AI agent in your factory. The reasoning behind those other technologies, it's business at the end of the day. You might want to have a digital product passport because it's an additional added value for your product, or you want to have an AI agent in your factory because you want to optimize it and access this capability that the AI is bringing you. But at the end of the day, you will still need to deploy something that from the layer of something that is standardized, because you will uptake the technology in a faster way. And that is something that we try to explain companies, because in reality, sometimes we're facing, especially South Europe, we're facing a lot of companies that they want to do Industry 4.5 or Industry 5 without doing Industry 2.0. And we need to be honest with them and tell them, please try to follow something that is going to be standard, try to be concise, and go for things that are going to be useful for you independently of the kind of applications you want to develop later. Because otherwise, we will make we will be making the same mistake that we've done years ago, that some companies, they digitalized and they don't know what data is for. So we try to push that, and I hope that answers your question.
Thank you very much, Ignacio, for your presentation. I will take from you the clicker. And again, a round of applause. So our next presenter, Dr. Jacopo Cassina, Industrial Data Spaces and Data Rooms for Cognitive Production. So please, the stage is yours.
Thanks a lot. So we saw that there are digital passports. We saw that there are the asset administration shell. We heard from John that everything is going into a cognitive layer for every kind of application. Okay, this is all very good, all very nice, but how do we share all this data? How do we share this data among companies? How do we share data to train these models? Okay, actually there is an answer to this question, and it is actually industrial data spaces. What are industrial data spaces? Are a way to exchange data in a standardized form, keeping sovereignty. Who am I? I'm actually Jacopo Cassina, the director of Syxis, which is a federation of Lithuanian companies, focusing on 3 pillars. Networking, so mainly SMEs, both technology providers and users working together with digital solutions, quite a lot, for circular economy. Actually, we are around 10 partners now and growing. From the partners, we have several digital solutions. Most of them are benefiting or are going to benefit from data spaces, which is actually the reason why we are so keen on them and we are focusing on them. So, again, what is a data space? It is a virtual space where data from different sources can be shared seamlessly and securely, keeping a degree of knowledge on who is going to use the data and how. Actually, this is standardized by the International Data Space Association, IDSA, in a standard which is called, with not so much fantasy, IDS. Why? Because data is a core component of a digital economy. We heard that. The volume of data is huge, but most data are unused or are kept in secret silos somewhere in the hidden folders of your company, and they will not be used anymore. So this has to change, and there is also a regulation that is upcoming in the next September, that is the Data Act. The Data Act implies that there should be an exchange of data, and actually proposes to use as a way to exchange data IDS, data spaces. Why is so important? Because actually we need balance as the force. I'm joking a little. And the balance is called the data sovereignty, because you have to balance the data ownership, security, and data value with the interoperability of data exchange in a sharing economy. So the data sovereignty is the capability to exchange data knowing who will use them and how. There is obviously a tool, a set of tools behind this, mainly open source. It is a federated data architecture with interoperability, traceability, and data sovereignty among trusted partners. The structure is quite complex, but not so much at the end of the day. And how does this operate? So if one has some data he wants to share, he can publish them. He can publish the metadata of them, so not the real data, only the metadata of them on the data space. Those who are interested in this data, for example, a digital product passport, I received my fabric, I want to check where it was produced. I can check them on the data space. I can see that the data are available from yarn producer 1. Then I see also which contract is implied to have this data exchange. I can accept the contract. And once the contract is accepted, we have a data transfer. You see, it's not a centralized system. It's a completely decentralized system. The data goes from yarn producer to fabric manufacturer, not through the central point. This is the difference between a data space and a platform. We have a couple of examples of this work, one which is almost already operational, and the other one which is an idea that we are pushing ahead. The first one is Machinery X. It's a data space for industrial machinery. Actually, the first implementation has been on the metalworking sector. Uses OPC-UA, so more or less in the same domain we are talking before. Is coherent with the upcoming regulation, and has been developed in collaboration with USIMU, which is the Italian Association of Machine Producers. So actually it's 300 machine producers, and we developed this with a first group of 17 companies. Now we have presented that at BIMU, which is an industrial trade fair for industrial machines, and we are now creating the association to run the data space concretely. It has 4 scenarios: local platforms, edge solution, cloud platforms that receive data already integrated from the field, and cloud platforms who will receive data from the local platform or the edge solutions, and has several advantages. And I think this is the most important part. First of all, the alignment of a technological management of data with a legal management of the data themselves. I know most of the people around here are probably engineers, so we don't care so much about regulation, law, and so on. Usually lawyers are not our best friends, but rather often lawyers are quite useful if you run a company. So it's good to keep them in the loop and to cooperate with them, especially not go against them. Is always not a good idea. Another advantage that can seem trivial, because actually it was discovered, I think, some millennia ago, is that if you have just one entry point in your company, or few entry points, one big door, highly secured, is usually much better than having plenty. If you have worked on IoT solutions, very often each machine, each IoT solution sends data through its own port, through its own peculiar way toward the peculiar server of the IoT company. With IDS, everything goes through a connector, which is much simpler. Obviously, it allows you to make more money, because it increases the effectiveness of existing business models. Actually, the real reason why we created Machinery X is because all the companies involved already have an IoT solution, but that their customers uses the IoT solution between 40 and 60% of the times. So only 40 to 60% of the companies buys the IoT solution, the others not. Why? Because we don't trust. We don't trust to send it out. Then you can also create new business models on data. Moreover, as I told from the very beginning, AI needs data. AI will become a commodity. We will have several layers of AI in different solutions and so on. We need a way to acquire the data and to make them a competitive asset for our companies. As what we did in the machinery sector was considered a success, actually, other associations in Italy started asking us to cooperate with them and create something else. And that's why we are starting now with an initial concept for data space in the textile industry, actually exactly for the reason of a digital product passport for the textile industry. Also here is important that we have a peer-to-peer approach. So it's not only that one single solution owns and has all the data, but we exchange the data one with the other. Data shared through the digital product passport specification, helps a lot with traceability, and actually enables data security and sovereignty, especially. With this, as I have finished, I think I have been pretty quick, and I have also 40 seconds left.
Jacopo, to help us recover a couple of minutes. Do we have any questions? One, two. Comment, question, everything is valid, an opinion. Everyone's starting to get hungry, Jacopo. So we're between
no problem.
lunch
I was
and
quick for the reason.
between lunch and one more presentation. So thank you very much for
Thanks
sharing with us. Jacopo is still going to be with us during lunch. If you were shy to ask any question in public, so you can approach to him. And then we reach our last presentation before we go to lunch, Digital Twin, Combining Technologies to Maximize Productivity. Fernando Ubis from Visual Components. Oh,
sorry, wrong name.
Okay, wrong name, I'm sorry.
No problem, no problem.
So you have the clicker, the stage is yours, and love the tool.
Yep, thank you. Hello, everyone. I know already that you are hungry and angry, so bear with me for a second. So my name is Jarkko Soikkeli. I'm from Visual Components. And long story short, what the Visual Components is, last 25 plus years we have worked with simulations. So we design a simulation software, and on that perspective or background, we have seen hundreds, even thousands of different projects done by hundreds of different companies. So different types of manufacturing systems, solutions, automation systems. So from our perspective, what is digital twin and why it is used by manufacturers? So that is what I'm going here. So if there is a greenfield production system, or for example, an existing production system that is drastically changed, we change the automation level, we add mobile robots, we add more AI for the production control, whatever the change is, you still have a concept. So at the very first stage, using, for example, any software in a sense, you start to think that how your solution looks like. This is always the very first stage, your very initial plan. Early days, I have seen factory plans that are actually implemented, drawn behind an hotel receipt. Luckily, nowadays we have different types of tools where you can do the initial design. And one point to mention, the designs nowadays are brand agnostic. And I will come back to that notion later on. But at first stage, you create your plan, how your production will look like, and you use this plan to communicate with the stakeholders inside a company, for the decision makers, to your customers, and you create deliverables, and you cut the time on discussion. When they see the production in action, they know what you are planning, what you are selling. And then when there is some kind of a consensus, okay, this is the plan, then we start to analyze it. And already today we have heard many presentations of data. So this stage requires that data. We need to know what kind of products we produce, what kind of assemblies or product details there are, what kind of processes there will be in different stages of production. And of course, then how the product moves from process to another in the production plant. Of course, if you have a fully greenfield system, then some of the times may come here. But that's not optimal. And in here, many times the data that you use to actually analyze the system may be generated, for example, by AI from a really low amount of data. But to run a simulation of 2 weeks, you need it a little bit more. Then when the plan is done, you actually start to commissioning it. So in this stage, latest, the hardware and the third-party softwares and others start to step in. How you control the production, what kind of PLCs you have, what brand of robots you have. And in there, you still have the same digital model, but now it is not controlled by the internal logic of a simulation anymore. It's connected by Beckhoff ADS, for example, or in the case of robotics, to a virtual robot controller, or actual hardware controller. So you may see where this presentation is going. So instead of having an independent platform for simulation, now there can be multiple softwares controlling mobile robots that are connected to simulation, or different brands of robots connecting it. But of course, the controller doesn't know. Is it controlling a real robot, or is it controlling a simulation or some other tool? And in the last step, when the system is already running, you are producing. The biggest things in here, of course, are, in our case especially, the remote monitoring and the continuous improvement. The production nowadays changes all the time. Those days are gone that you buy PLCs from this provider, I buy robots from this provider, and then we produce something for next 20 years. Does not happen anymore. So instead of that, new products are introduced really often to a production. And you don't want to stop, for example, a production to teach a robot. That costs a lot of money. So instead of that, you have in this case, you have an accurate model from your real production cell on the simulation side, and you teach the robot purely on calibrated environment in simulator. And then you just commit the changes during one night, and the production continues. So, a slide that I borrowed from Jeff Winter. So, relating to the steps that we went before, we like the, let's say, the wording of digital model, digital shadow, and then the familiar one, the digital twin. And these are, depending on who you talk, are used a little bit interchangeably. Like, it depends on who you discuss with. They say a digital twin, they may mean just a normal simulation model that is not connected to anything. And sometimes another way around. So how this idea relates here, in production we have a concept phase, engineering, commissioning, operation phase. If you use digital world with it, you have a conceptual design, simulation and analysis to check your plans, the virtual commissioning, and then the remote monitoring and operation. And now we move in spectrum. At this very end, we have a digital model. But when we start to include softwares, we start to include actual production softwares, IRPs, mesh systems, control softwares, PLCs, robot hardware, and all the other things. Then we reach the digital twin. It's not a single truth, it's something between. Why? That's actually omniverse. Anyway, why companies invest on digital twins? Why companies invest to these features that we have heard today? A bit rough, but it is what it is. So in the very beginning of the day, this already was mentioned. Companies, of course, try to gain benefit on the new technologies, stay on the edge of development all the time. If we put this into practical terms, the biggest reasons why simulation and digital twins and others are used is the risk assessment and time saving, those two. They don't want to make mistakes when they plan the new things. And they want to start designing the new production system parallel. So the PLC guy starts at the same time than the robot guy teaching the robot. When the layout is still designed, software guys are working at the same time. Of course, then, when we go to simulation side, not that much on the digital twin side, is of course the initial plan. How efficient the production plant is. What kind of wastes there are. And then the very last thing that was mentioned, for example, at the beginning of this segment today, is the manufacturing nowadays is super volatile. It's complex environment. It changes all the time. And it's fully data-driven. And if nothing else, if you don't remember anything else from this presentation, is this sentence. Sorry, now I'm a bit rude, but this applies so well in the simulation world. It is the shit in, shit out sentence. Sorry. You put wrong information in, you get wrong information out. So, okay, simulation is data-driven, but you need to make sure that you put correct information in. That is the reason why, for example, an AAS or different types of data models that define what the data actually is, what it means, that is important. But that's what I like to show. This is our perspective. What is the digital twin? It's not a solid thing. It's kind of like a spectrum of things. And also a little bit why the actual industry is using it. Thank you, everyone.
We also call it garbage in, garbage out, but
Sorry.
I think yours is better, especially before going for lunch.
Yeah, and now everyone remembers at least something from what I taught. So.
That's for sure. Do we have any questions? One question, otherwise we don't go for lunch. I want one question before going for lunch. Okay, we have one question.
Yeah, we have the one question.
That's the problem when you have smart engineers on the audience. So thank you very much for your presentation. Thank you very much for joining us for morning sessions. We have 45 minutes for lunch, and then we come back with some exciting.